I'm Genoa Beniga, and in this video I will discuss about neutral geometry, which is the theorem of Saccheri and Legendre. Neutral geometry is between the Euclidean and non-Euclidean geometry. Because of Euclid's fifth postulate, which is a little bit controversy, other mathematicians chose to become in the middle of Euclidean and the non-Euclidean geometry. So they form or build a new geometry, which is the neutral geometry. And one part of a neutral geometry that prove a triangle ABC, which has given an angle of A. Triangle sum of angles of triangle ABC is equal to angle A plus angle B plus angle C, or is less than 180 degrees. The name of the theorem is the Saccheri-Legendre theorem. In this video, we will prove it. Okay, the first move we're going to take is proving that given triangle ABC with point D, which is not on the triangle ABC but collinear to ABD to AB, when B is between A and D. So given angle A, angle B, and angle B. First, we know through linear pair postulate, B plus D here is equal to 180 degrees. Then we all know through exterior angle theorem that A is less than D, because A is the sum, because D is the sum of A and C. Then through addition property of equality, we add both sides with B. A plus B is less than 2D plus B. Then we already know that D plus B is equal to 180 degrees through transitive property. A plus B is less than 180 degrees. Okay, this is now the second step. We need to remember this step because it is one of the important steps to prove the Saccheri and Legendre theorem. So, given triangle ABC and point between A and B, then we have angle A, C sub 1, C sub 2, D sub 2, and B. Oh, forgot. Wait, add angle D sub 1. There we go. We given again is the sum of angle ABC, sum of the angle of the triangle ABC plus 180 degrees is the triangle, the sum of the angle of triangle ADC and sum of the angles of triangle BDC. So we'll know that. Then we just need to substitute their angles. First, the triangle ABC, the sum of the angles of triangle ABC, i.e. triangles, angle A, angle C sub 1, angle C sub 2, which represents the angle C, and angle B here. We also know that D sub 1 and D sub 2 are equal to 180 degrees or the linear pair postulate, so here is equal here. So if we substitute it, and we also going to solve for we're going to substitute the other part of the equation. It is like the organized version of the first equation. So A plus B plus C sub 1 plus C sub 2 plus D sub 1 plus D sub 2 is equal to A plus D sub 1 plus C sub 1 plus B plus D sub 2 plus D sub 2. Hello, and now after we finish the step 1 and step 2, we're going to do our third step. First, we have here two triangles, triangle ABC and triangle XYZ. To do our third step, we should know that the sum of the angles of triangle XYZ is equal to sum of the angles of triangle ABC, given that even though X is less than or equal to 1/2 over A. So we need to prove that first. Now we have a given here two triangles, triangle ACB and triangle ADB, which M as the midpoint of AD, so we can say that these segments are equal, because of midpoint. And with Euclid's theorem of vertical theorem, we can say these angles are also equal. So we can say that triangle AMC and triangle DMB are congruent through side angle side theorem of Euclid. Then we go here, the sum of the angles of triangle AMC is equal to sum of the angles of triangle DMB, which we already proved in our step 1 and step 2, because they are both triangles. Then we can also say that the sum of the angles of triangle ABC plus 180 degrees. Through our second step, we proved this, that it is equal to triangle AMC plus triangle AMB. We can see it here as the triangle ABC and the triangle AMC, and triangle AMB. And we can also say through our second step that the sum of the angles of triangle ABD plus 180 degrees, sorry, I forgot to put the degree symbol there, is equal to sum of the angles of triangle DMB plus sum of the angles of triangle AMB, again by the second step. So ABD plus 180 degrees because of the linear postulate there is equal to sum of the angles of triangle DMB and sum of the triangles A and B. We can see here that ABC and ABD, they're all the same, and we just, oh, look at here on the first statement, in our second statement, that angle of sum of the angles of triangle AMC is equal to sum of the angles of triangle DMB. So these two parts are equal. So we could eliminate them both by addition property of equality. So a little bit of that, then we will have sum of the angles of triangle ABD is equal to sum of the angles of triangle ABC. Then since angle CAB here, CAB is equal to A sub 1 plus A sub 2, we can say that either of them is either, if angle CAB is equal to 1, we can say it's either 1/2 of angle CAB, less than or equal of 1/2 of angle CAB. There. So how we can say that? First, if both sides are, if the both angles both are greater than the 1/2 of the angle CAB, if we add them, we can see that it's going to be more than the angle of CAB. So we can say at least one of them is less than or equal to CAB. Okay, finish the second and third step. So we're going to our fourth step, finally our fourth step, but this is the most complicated one. So what we're going to do is we're going to use the proof by contradiction. We're going to prove the opposite of what we need to prove. So we need to prove that sum of the angles of triangle ABC is at least, at most, greater than 180 degrees. So the opposite of that, sum of the angles of triangle ABC is greater than 180 degrees. And the exceeds of that 180 degrees will be represented as x. So okay, we're going to write it as the angle of triangle ABC is equal to 180 plus x. And other thing we need to do is the Archimedean property of real numbers, that states that for any small numbers there exists some constant that you can multiply by so that it will exceed any fixed number. So I want the 12 sub n here will represent our sum number, because why 2 sub n? Because we need it really in our program. So you can represent any number there. 27 times x, which is the smaller number. It's only our representation, is equal to which is our fixed number, the angle A. So here we have the given triangle PQR as A7 is the angle E, then angle Q, and angle R. Remember third step. Third step is the sum. The triangles have the same sum of the angles, even though the one angle of the small triangle is one half of the other. So if we're going to represent it, it's like one half of A is equals the same. Then another one, we continues to small it out, 1/4 of A, then 1/8 of A. So 2/4 is like a power of 2 in the base 2. So we want to represent this as the continued part of the triangle, which is became smaller, smaller, smaller. So the smaller vertex is the smallest vertex is we're going to represent A sub n, so it will be less than or equal to 1/2 raised to n times A. Because we remember the third step, we represent the vertex as A. So next is this like this. We just copy it and change the triangle, because as we use the PQR as the representation of the bigger triangle ABC, but remember that all triangles have the same sum of the angles. So here you can say that the sum of the angles of triangle PQR is equal to 180 degrees plus the exceeds, which we represent as x. But remember, these numbers also the same of the sum of the angles, so we can just substitute it. So sum of the angles of triangle PQR is equal to AN plus Q plus R. Okay. Then we're going to use the Archimedean rule, Archimedean property of real numbers, which is 2n times x is equal to that. What is this? Greater than angle A. So here, 2 raised to n times x is greater than A. A little algebra, we can get that 1/2 raised to n times A is less than x. Then we're going to thus A sub n is less than x, algebra once again. Then we can conclude then A sub n plus 180 degrees, I forgot to get the degree sign, is less than to x plus 180, which is also equals to an plus q plus r. Remember that x plus 180 and an plus q plus r, which we can use the transitive property of equality. Then algebra once again, we can have 180 is less than q plus r. Use both sides. We eliminate the a sub n. So in this answer, we can say that it is contradict to which we proved later in our first part, in our first step, that which is a plus b is less than 180 degrees. If there is one contradiction in our answer, so we can say that our proving here is false, which leads us to our real intention, which tells us the sum of the angles of triangle ABC is less than or equal, because it is not greater than, so it must be equal or less than to 180 degrees. So that's it.
That's it.